All right, so now we want to do an example where we go from a mathematical Boolean expression to some structural Verilog. And normally the steps that I'd recommend are taking the function and drawing out the actual logic diagram. The reason for that is because with our structural Verilog, we have to define all of our wires for our intermediate steps here. So I'm not going to do that for this case, but it's something that I would highly recommend. But I'm just going to go through and identify where kind of the intermediate steps in this function are. So of course we're going to have an a naught. So let's just start our list right now. Wire, and we're going to have an a naught. What else are we going to have? Well, we're going to have to and our a naught and b together. So we'll call that an x. And it doesn't look like we're actually going to need any intermediate signals because we're going to take x and we could OR it with c, but technically if we have this OR in parentheses and then knotted, it becomes a NOR. So we could just use our NOR function and save a spare wire. So why don't we do that? So it looks like we've only got 3 wires here, or 2 wires, sorry. So let's get the not out of the way. So we've got not, and so remember we always do our output first, an, and our input is a there. All right, and we end that with a semicolon. Oops, something I forgot in the previous video that can be important, or something I always forget, is when you define your module, you actually have to have a semicolon after it. It's just kind of a weird Verilog syntax thing that I always forget about. But usually the compiler will throw an error if you forget that. All right, now let's AND our A naught signal in B. So we've got, we're outputting that to X, and our inputs are A naught and B. So this is generating the output of this term right here. And putting it in kind of, you can think of it as putting it in a variable X. And now we need to NOR that. So we need to, well, first our output for our NOR gate is just out, right? This is our final output. And our inputs are X, right? We've got this term here. And our other input is C. And there's our final form for our structural Verilog. Like I said, it can be much, much easier to visualize if you draw the diagram for it and kind of label where your wires are at and make sure you've got all of your ducks in a row before you start the bulk of the code writing.